All right, let's look at chapter 6.3 homework. This is page 429, 1 through 21. So I'm just going to work through a couple of problems that may be of use to you. So number 9 says find the general solution of differential equation. We start off with square root of 1 minus 4x squared times y prime is equal to x. And we can rewrite y prime in a different form. So let's rewrite y prime as dy over dx. I'm going to pull this in front. And now we're going to begin separating variables. So y is on the left, everything else on the right. And now we can take the integral of both sides. So integral of dy will simply leave us with y. But the right side here, we have to go through u substitution. So we let the u value be what's inside the radical. We let u equal to 1 minus 4x squared. Du over dx is negative 8x. dx is du over negative 8x. We make our substitutions. Denominator gets replaced with u to the 1/2. X is still in the numerator. Du over negative 8x. The x's cancel out. Pull the negative 1/8 in front. And we also need to bring the u up to the numerator. Now we're ready to apply power rule. So u to the 1/2 over 1/2. Flip the 1/2 to be 2. So 2 times negative 1/8 is negative 1/4. So we simply have negative 1/4 u to the 1/2 plus c. And now replace our u value back in terms of x, and we can put the radical back. And the left side, the integral of dy is simply just going to be y. Okay. All right, number 11, y ln x minus xy prime is equal to 0. Let's rewrite y prime as dy dx. Next step, we're going to start separating the variables. So in this case, we have, I'm going to have the dy on the left side and move the y ln x to the right side. So that's negative y ln x. So we're just rearranging and trying to get it in a way where we always need to have the dy up in the numerator. So we're going to isolate the dy first, and then it's okay to have the y in the denominator. Okay, so we have dy over y is equal to, rearrange everything, dx on the right, x on the right as well, natural log of x over x dx. So now we can take the integral of both sides. So integral of dy over y, we go through, this is in the form of 1 over u, so we take natural log of u. On the right side, we have to go through what looks like u substitution. So we want to choose the appropriate u value. We don't have a rule for ln of x over x, so we have to look at u substitution. U value is natural log of x. Derivative is 1 over x, so dx is simply x du. Okay. So the left side is natural log of the absolute value of u, which is y, and then is equal to u over x times x du. So the numerator got replaced with ln of x. Ln of x got replaced with u value, and the dx got replaced with x du. The x's cancel out, so we're simply left with integral of u. Okay, we can apply power rule, which is u squared over 2 plus c. And now we have natural log of y is equal to natural log of x quantity squared over 2 plus c. Okay, we still need to solve for y. We need to get y by itself. So we're going to take exponentiate both sides with e as the base, because we know that natural log and e are just going to cancel out nicely. So we get y by itself on the left. On the right side, we have to do some more cleanup. E to the ln of x over squared over 2 plus c. We can split this up into e to the ln of x over 2 quantity squared times e to the c. Okay, remember we have the product rule that we can apply for multiplying like bases. And remember, e to the c is simply going to be a constant. We can just pull that c out to the front. So our general solution is y is equal to ce ln of x quantity squared over 2. All right, let's look at some more problems here. Number 13. Find the particular solution satisfying the initial condition. So we want to find the solution for this differential equation, but then we have a specific ordered pair that we can use to solve for c. Okay, but first we need to find the general solution. Replace y prime with dy over dx and start separating the variables. So I'm going to move the e to the x to the right. The y and dy will stay on the left. Multiply the dx to the other side. So we can take the integral of both sides now that we have the y's and the x's separated. So integral of y dy is simply y squared over 2. Integral of e to the x was simply e to the x plus c. And if I multiply the 2 through, I'll get y squared is equal to 2e to the x plus c. And it's going to be a little bit easier to find the c value at this point rather than waiting for the square root. So we're going to solve for c here. Okay, so we're going to plug in the ordered pair. The ordered pair is 0, 4, so plug 0 in for x, plug 4 in for y. We get 4 squared is equal to 2 times e to the 0 plus c. E to the 0 is simply 1, so we have 16 is equal to 2 plus c. C is equal to 14. And now we have our equation. Y squared is equal to 2e to the x plus 14. Okay. Now we can solve for y. So y is equal to plus or minus square root of 2e to the x plus 14. We have two solutions, but we have to figure out which one is going to work with that ordered pair 0, 4. So we want to test the equation that will satisfy 0, 4. Plug 0 in for x, and we want the positive version because we want the right side to give us positive 4. Okay, so y is equal to plus positive square root of 2e to the x plus 14. Okay. All right, let's look at 15. We have y times x plus 1 plus y prime is equal to 0. Given that we have an ordered pair, negative 2, 1. So we want to find the general solution first. Y prime gets replaced with dy over dx. Dy dx on the left, everything else on the right for now. So once we have dy up in the numerator on the left side, now we can start moving things around. So bring the y over to the left, dx to the right. Now we have the y's on the left, x's on the right. We can take the integral of both sides. So we have dy over y. This is natural log rule. These are power rule here. So natural log of y is equal to negative x squared over 2 minus x plus c. Exponentiate both sides. We want to bring that y from under the natural log function. So exponentiate both sides. The left side will cancel out to be just y. Now this we can represent, split this up and have this as e to the x squared minus over 2 minus x times e to the c using the product property. And we know e to the c is a constant, so we can put a c in replacement of it and pull the c out in front. So now we have a general solution. We can plug in the ordered pair and see if we can solve for c. Okay, so negative 2 goes in for x, and 1 goes in for y. And this reduces to be negative 2 plus 2, which is 0. E to the 0 is 1, so c is simply equal to 1. All right. So our specific solution is y is equal to 1 times e to the negative x squared over 2 minus x, or that 1 will just drop out and we say y is equal to e to the negative x squared over 2 minus x.